Good morning. Welcome to Physical Science in the AM. I'm Joel Sundon. We're going to review a little bit because there's a lot of people missing. Energy changes. You guys got this out. Here's what we went over yesterday. Especially from the first page that there's energy changes, and that's measured in joules, and heat is a type of energy. We use this triangle H, delta H, as the symbol for enthalpy. Enthalpy refers to the heat energy changes in chemical reactions, not just chemical reactions, but that's what we'll look at here. It also works in physical change and nuclear reactions as well, but we're focusing on chemical change. There's three ways that we are going to look at to represent energy changes in our class. One is using a graph. I'm going to pause here to update as these people come in. Okay, I'm going to talk to you quickly about this. We've already gone over it, but thanks. So we've got the E, enthalpy. We can think of it as energy on this graph, and we're not putting numbers on these graphs on the sides, except on 100, 200, etc. We're just getting a general idea. Here's a graph, and I'm starting with that. This is where you start. The reaction goes from left to right. So say we started with hydrogen plus oxygen. And it reacts, when it reacts, it drops in energy, minus 486.2 kilojoules. It forms water. This shows you that the reaction loses energy. We have a word for that, exothermic. Exit. Energy is exit. Energy, though, the same energy from there is included in the balanced reaction. We write out the reaction, and then we include the energy here. That's 486, not negative though, because you're showing that as the system. There, on the right-hand side of the product side. Or you can write it separately, and we'll see this a lot. You can write out the reaction, and then as a separate item, it doesn't have to come last, it come left. Delta H, that's where you include the minus sign. Show that it's losing energy. It's endothermic. If I wrote that down, second, I know why. I wrote it down on this page. And this is an exothermic reaction. It means that energy exits the reaction system. Okay. So I know I'm going quicker than it's possible to write everything out, but you get a chance to review. Just catch on. Let me look at another one. Okay. So the same thing just to review, but this time an endothermic reaction. I'll tell you what I mean. I gave you this reaction, and I said, represent the information in two ways. Whole numbers in the balance. So first thing you have to do is figure out what's a number we can multiply everything by, get rid of this fraction. Not a 4. Out of 2. So if you multiply everything by 2, works. So what we did was times 2, 7 times 2 is 14. Times 2, 704 times 2 is 14. Times 2, 3 halves times 2. That's the first way to represent energy, or the first way we list it. I'm not going to anything for it. Energy is included. Right away, I can tell this is endothermic because the energy is added. Endothermic, the energy ends up inside the exothermic, the energy exits. From this, scratch this out. You've got this way, just write out the reaction normal. Now, because I scratch that out, do I have to include it as a delta H? Change in enthalpy. And because the 1408 here, part of the reactants, we put plus slightly. That energy is added into the reaction. On a graph, that exact same stuff starts low and energy increases by plus 14 ohms. There's three ways. I'm going to pause the video, update something, and then we're going to take a look at what we want. This is where we left off here. People from the other day that was on the photo field trip, they'll pick up on this, I think, by doing it. So if we flip the page, assignment, like this is in class guesswork. Okay, we're all working on here. There's a skill I want you to pick up on, and it's working with fractions. A balanced reaction, we'll see why eventually, why we need it. First thing I want you to do, though, is some of the underlines didn't show up on the photograph. So, these ones here, button number 4 and 5. Then we'll get back how to do this. Okay. So first things first, make sure 4 and 5 are underlined, because I don't think these showed up as an underline. Get it? And in this particular one, we're underlining the 3 skills. Okay. We're going to work through this, see how this works. Following, rewrite the equation with that delta H notation, but one more thing. You're going to do this for the reaction 1 mole of the underlying substance. So here's what we got to think. I've underlined CO in this. There's a 3 in front of the CO, carbon monoxide. I want to get 1. I have to divide everything by 3. That makes sense. Maybe it doesn't make sense why. It's a skill. But what I'm going to do and think of is I divide, well, this is a 1. You know how there's no number in front, it's a 1. So I'm going to go 1 divided by 3. 3 divided by 3. 3 divided by 2. 2 divided by 3. 25 divided by 3. I chose the 3, but the underlying substance had 3. When we do that, get 1/3. By the way, I only wrote that fraction there because it was done a few years ago. And should have typed that without going too fast. That's no reason why I prefer flat fraction. 1 flat. Line 3. Everything else is a 1, a 1, 2/3. Now, this part, the 25 divided by 3 is the 8.3. Pop around. Don't put the decimal 3. Why negative? That's what I want. Well, if it's negative, that meant it was exiting the system, exothermic. And you see how this 25 kilojoules was on the right-hand side. The energy is on the right-hand side. Leaving, exiting the system, exothermic. I don't know what that was. Anyways, one thing, and it doesn't say to do this, but I'm going to get you guys to practice, is I want you to then categorize if this is exo or endothermic. This is exothermic. I'll maybe go through number 2 with you. Here's water. Then I'll let you do the others. You can go through number 2 because the energy is on the left side. 96 kilojoules is on the left side of the reaction. When you see energy on the left side of the reaction, it is endothermic. I want you to remember that. Energy ends up inside the reaction. But the math part of it, not heavy duty math, but if I want to get 1 mole of HCl, there's 2 particles. I've got to divide everything by 2. So I can do this in my head. I'm sure you can. So 2 HCl divided by 2 is HCl plus, oh, nothing else because that 96 is going to come later on. 96 divided by 2, 48. Use the calculator. I'm going to put that over here because we want delta H. Not just 48, it's positive 48 because it's endothermic. It's on the left side. Put that there. And we return to the reaction. Keep writing. Now, H2 is 1, but it's divided by the number 2 because that's what we wanted. I'm going to put 1/2 H2 plus 1/2 Cl2. Same reason. Come on. Okay. I want you to do the same thing with all of these. Practice, we'll pick them up a little. Okay. Write down the word endo or exothermic, depending on the energy that's there for examples, and rewrite them with the calculation. Okay? I'm going to pause the video while you guys work away. Okay, taking a look at this. 4 NH3, 4 ammonias were underlined. That means you need to divide everything by 4. That turns this into 1. And I don't need to write down the 1, but I'll put it there. NH3, ammonia. 5 divided by 4, I'm just leaving it as a fraction, 5/4. Not too upset if you didn't notice this, but it's actually a double arrow, and that's more of a grade 12 thing. This is right the same. NO, hydrogen monoxide. There's 4 of them, so 4 divided by 4 is 1. I'm not going to write the 1 down. Yeah. 6 divided by 4 for H2O. Now, you recognize that 6 out of 4 is a fraction that you can reduce, dividing by 2 each. That's 3 out of 2. 3 halves. If you put 6 out of 4, I'm not too upset. Plus 1170 kilojoules. That's on the right-hand side. So when I do this delta H tag, I'm going to use a negative sign because it's exothermic. I'm going to write that down. And negative 292.5. Try to squeeze that in here. Kilojoules. Exothermic. Energy exiting. I don't know. So this time the hydrogen was underlined has a 3 in front of it. So one group of N2 divided by 3 is the fraction, 1/3. 3 divided by 3 is just one group of hydrogen. 2 divided by 3 is the fraction. Delta H notation, it's on the right-hand side, so I know it's negative. 92 divided by 3 is 30.666 repeating. I'm going to keep it to 2 digits, but if you put the decimal 7 down, that's fine. I'm going to call it 31. Okay? Tell me about the same number of sig figs that was there, but you didn't. That's fine. Okay, number 4, I go with the 2 carbon monoxide. monoxide is everything divided by 2. 2 divided by 2 is one group of carbon dioxide. 566 divided by 2, I'm going to put this over here right now. Positive, because it's endothermic. I didn't write that down. Just go back and say exothermic. Okay, back to this problem in red. 566 divided by 2 would be 283. Arrow. So back to this. 1 group of carbon monoxide. 1 divided by 2 is the fraction half. Okay. And number 5. Divide everything by 4 because it's aluminum that can be underlined. So 1 group of aluminum. 3 out of 4 must. 2 out of 4, which I know is a half. And the delta H, this is exothermic, would be negative 840. All right. Got some skills there. Oh, already. Any questions on these ones? Obviously, there's a few more follow-up. Okay. Take a look at this next one, and we'll try these. Each of the following reactions written in delta H notation, rewrite using whole numbers this time using fractions. By the way, these are balanced with fractions. Whole number balances and energy as a term. So we're putting the delta H number inside. Then give it also a graph form. I'll do the graph for this, but let's talk about these. So when I see positive delta H, that means it's endothermic. That means that it's going to go on the left-hand side, the active side of the energy. Number-wise, though, I've got to clear the fractions, whole number balances. That means I have to multiply everything by, well, out of 2 here, I see 2 halves, CL2. I'm going to multiply everything by 2. So that's where this 2 times 2 is 6. Times 2, oh, sorry. I need to put this endothermic 173 times 2. Then on the other side of the arrow, 3 times 2 is 6. 3 halves times 2 is the number 3. That's where that came from. Okay. Now, as far as a graph, I'll do this instead of as volume. Endothermic means from left to right, does it increase or decrease in energy? Look at the delta H, it tells you it's a plus. So when I do a graph, put E, enthalpy increase, reaction time, where it starts is with FeCl3, 56. It goes up because 346 kilojoules under that. How much does it go up by? I'm going to put down the plus 346. And it increases the energy of the materials and you end up with 6. This is the exact same information another one, right? Who knows? About this. You're going to try these other problems. On the next page. That should take us to the end. We should be able to correct it in the last 5 minutes. Okay? So the next 11 or 12 minutes, I want you to work on this. Okay? Don't be shy. Give it a try. Just to give you a start on this. The first one, you were supposed to multiply everything by 2. Work it in. This is what it should look like. Keep working away at these. Another answer. Put up the last answers. Here's 3 and 4. Check over. And 5 in a second. I'll just wait. Here's 5. And that's it. Finish up.